today we are beginning a new chapter, chapter 5. And again, we're just working on our algebra skills, kind of expanding the different things that we know how to do in order to simplify things, to get things to be in their simplest form. Okay, so today we are going to do denominators with exponents. Okay, so we've done exponents before, but now we're going to do denominators. Okay, so here we have w over x times y over z. Now, what we can do is just multiply the tops together and multiply the bottoms together. I'm sure you've seen this before. And then the other thing that we know we can do is cancel stuff. So if I have wy over xy, I can cancel the y's and get w over x. Okay, so those are two things that you're probably familiar with. Now, I make a little mistake here. I'm just reviewing the three laws of exponents. A to the m times a to the n should be a to the m plus n. I correct it later in the video, but for now it's just going to look incorrect, but you guys know what the correct version is. Number two is we have ab to the m. We distribute the exponent only because a and b are multiplied. Okay, if there's any adding signs, do not distribute the exponent. And then the last rule is that if I have a to the m and I raise it to another power, I'm going to multiply those powers together, m times n. Okay, now we have a couple new rules, okay? So suppose m is greater than n, okay? And I have something like a to the m over a to the n. Then I'm going to subtract the exponents. I'm going to do the top exponent, which is bigger, minus the bottom exponent, which is smaller. Okay, and same thing, if the bottom exponent is smaller, then I'll do 1 over a to the smaller exponent minus the bigger exponent. So it's pretty straightforward. I don't think you guys will have much of a problem with this. You can also think of canceling rather than subtracting, but sometimes knowing that you can subtract is also helpful. And then the last rule, it's kind of similar to rule 2, is that I can distribute an exponent to the top thing and to the bottom thing. Okay, so that's going to be very helpful for us later on. So let's go ahead and do some examples, which is the best way to learn math. So if I have 5t cubed over 15t to the 5th. So 5 and 15 are going to cancel. I'm going to be left with 1 and 3. Okay, and then I can take the bottom exponent, which is bigger, and do 5 minus 3. 5 minus the top exponent, which is 3. And if I do that, I get 1 over 3t squared. Okay, you can also think of canceling out a t cubed out of each one, and you're left with t squared on the bottom. Whichever way you want to think of it, it doesn't really matter. Just know that you are subtracting because later it will be useful to subtract because it gets a little bit more confusing. So if I have 2u times 3u over v squared times 2v squared, right? I'm going to take the tops together and multiply them. That's why I said that in that kind of weird way. But first, let's go ahead and cancel a 2 out of here. Remember that we can cross out things top and bottom if everything's multiplied, right? Okay, now I'm going to fix that one rule that I miswrote, okay, because we're going to add the exponents. So on the top I have u and u cubed, so when I add those exponents it's u to the 4th, and then the bottom is also v to the 4th, so I just get 3u to the 4th over v to the 4th. Again, pause the video and work that out if you need to, whatever you need to do to learn best. Let's say I have another problem, 2 to the h squared over k cubed, and then that's all squared, and then the bottom's all squared. Okay, don't just cancel out the squares here. That would be wrong. Anyway, we're going to distribute the square across everything that's multiplied. See how nothing is added? We're going to distribute it across everything that's multiplied on the top. And then on the bottom, make sure that you square the negative. If I square the negative, it ends up to be a positive. Okay, then once I do all of that, I've distributed the squares. I can cancel those h to the 4ths. And then I can also do the bottom k exponent minus the top k exponent, which would be 8 minus 6, which is 2. So I get 4 over k squared. Again, do that more slowly if you need to. Rewind the video and see what I do. Anyway, we have another example for x squared over y z cubed, and then this is times z to the 4th, or z over 2x to the 4th. So I'm going to distribute that exponent as my first step to the top and the bottom, okay, and make sure you distribute it to the 2, which is 2 to the 4th is 16, and to the x, so it's x to the 4th. Okay, then I can cancel out, I'm going to show canceling out this time. Cancel out a z cubed, and I get z. Cancel out an x squared, and I get x to the squared on the bottom. And then I cancel out a 4, I get 4 on the bottom. And I end up with z over 4y x squared. Suppose I have another example, and I just have x to the n plus 1, y to the n minus 1. This is where minusing is going to come in handy, because it's a little bit confusing in this format. Okay, so I know that I'm going to do top exponent minus bottom exponent for x, because n plus 1 is obviously bigger than n, x to the n, right? Or sorry, n plus 1 is bigger than n. Okay, so I subtract the n from the top exponent, the n's cancel, and I do the same thing with y. I do y to the n minus n minus 1, and make sure you distribute that negative so that I end up with x over y. Okay, again, you should go back and pause the video if you need to work these out, but otherwise, good luck on your homework.